Here's an introduction to logarithms. Here's my little joke, logarithm, and a little bit of trivia. The MIT a cappella group is called the Logarithms. On our agenda, we're going to learn why do we even need logarithms. It's going to involve an inverse. We're going to convert between exponential and log forms. We'll do some special properties and we'll talk about the common base. Let's get ready. You're going to need pencil, notebook, and calculator. And let's just look at this unknown exponent. So here we have a statement that says 2 to the x equals 8. Sometimes we're going to have to solve for that exponent. So in this one, we can figure it out because we know that 2 to the 3 is 8. Therefore, x is going to be 3. Sometimes we might need to solve it graphically. We saw this example and we don't know our t up in the exponent. So we divided everything by 7,000 and then we graphed the left side, graphed the right side, and we found their point of intersection. So we can solve it graphically, but that takes a while. So what about solving it algebraically? We would need to undo an exponent. So here I can't just see the answer. I don't know 3 to the something equals 8. I can estimate because 3 squared is 9. So I know that x is going to be a little bit less than 2. But we want to figure out how to solve it algebraically and exactly. Remember inverses? Addition and subtraction go together. So if you're trying to undo addition, you would use subtraction. Multiplication and division go together. Quadratics or something squared goes with a square root and they undo each other. So now we have exponentials and logarithms. A logarithm is the inverse of an exponential. A logarithm is the exponent to which a specific base is raised. So when you don't know the exponent, you're looking for a logarithm. So let's just start by looking at the forms. Here, these are all completed exponential forms. In the first one, my base is 2, and we're going to try to rewrite it in logarithmic form. So when you write it in logarithmic form, you use log for log, and you keep the base the base. That's really important. The other piece that you want to remember is that when you're using the log, you're trying to find the exponent. So the answer is the exponent. So I'm going to write this as log base 2 of 64 equals 6. It equals my answer. It equals my exponent of 6. So log base 2 of 64 equals 6. That's how you read that. Log base 2 of 64 is 6. Let's try this one. We're going to keep this 4 the base, and this 1 has to be my answer. So log base 4 of 4 is 1. Log base 5 of 1 is 0. So I can get logs to equal 0. That will be okay. 6 to the negative 2 is 136. We know that with negative exponents, it means a reciprocal. I'm going to keep my base 6. So I write it as log base 6 of 136 equals negative 2. So logs can equal negative numbers, and that's okay. And on the last one, we have our unknown exponent, which means we're going to be equaling x. Keep your base of 3. So log base 3 of 8 equals x. We're going to stop there. We don't know how to solve that yet, but we just need to get used to going from exponential to log, and vice versa. We need to be able to go from log to exponential. So here's my base. And then remember, the answer becomes the exponent. So it's this little back and forth motion. 10 raised to the 2 equals 100. 10 squared equals 100. 7 squared equals 49. 8 to the negative 1 is the reciprocal, so 1/8. 5 to the 1 is 5. 12 to the 0 is 1. Notice that 12 to the 0 is 1. I could have any number in my base. I could have log base 100, and that I would still have log of 1. So let's try to use what we just talked about in converting to figure this out. So log base 2 of 16, we're actually trying to solve a log equation. I want to solve it right now by switching to exponential form. Here's my base. I'm going to go to my exponent. So 2 to the x equals 16. And at this point, we just have to think about it. Hopefully know your exponents with a base of 2. So this becomes 2 to the 4 equals 16, so x is 4. Here we have log of 1/2 of 8, log base 1/2 of 8 equals x. I'm going to write that out because it's easier to see this way. And then I'm going to rewrite it in exponential form, so it becomes 1/2 to the x equals 8. Well, I know that 2 to the 3 would equal 8, but now I have 1/2, and that's basically putting a 2 down into the denominator, the reciprocal. So this must be 1/2 to the negative 3 equals 8, because that would be reciprocal, which is then 2 to the 3 equals 8. So here, x equals negative 3. Here are some special properties. So you may have noticed as we were doing some conversions that if you have the same base and the number that you're taking, the answer is always going to be 1, because base to 1 is always the base. You could have log base 100 of 100 and it's going to equal 1. If you're taking log base whatever of 1, it always has to equal 0, because any base raised to the 0 is going to be 1. And what about this last one, log base b of negative 8? So let's just call this x for a second, and we'll think about our exponent form. B to the x equals negative 8. If b was positive, if x was positive, it would be getting bigger and bigger. If x was negative, I would have a reciprocal. So this is never going to be true. We are not taking the log of negative numbers. When we get to graphing, you'll see that as well. Logs on the calculator. So the common base in our number system is base 10. The common log is base 10. So if there is no base written, then it's an assumed 10. So you might see something like log base 32, log 8, log 20. Those all have an assumed little 10 there. You can write the 10 if you want. But if you see it on worksheets or SATs and there's no log base written, then it's an assumed 10. So let's try that on your calculator. You're going to find the log button on the left column. The calculator using the log button only uses log base 10. So if it's just log of a number, then you can hit that. So go ahead and try log 32. And you should get 1.505. I am going to ask you to go to 3 decimal places. So let's think about what that means. If I think of it in terms of exponent form, that's 10 to the 1.505. Must be 32. You could try that out on your calculator as well. So 3 decimal places, and using the log button only if it's base 10. So what if it's not base 10? Here we have log base 3 of x. If it's a base other than 10, you're going to have to go to math and then go down to a log base. So you want to go to this log base, and then it's going to pull up this, and you're just going to substitute it in. So you would hit the 3 first and then the 8, so you'd have log base 3 of 8. So let's just think about this for a minute, what we're trying to do. We're trying to solve what this log is, so it equals x. If I think about my exponent form, I have 3 to the x equals 8, and that's the same problem we keep coming back to. We said earlier we know our answer is going to be less than 2 because 3 squared would be 9. So when you do it on your calculator, you get 1.893. And if you test it, 3 to the 1.893, it is just about 8. So to recap, be able to convert between exponential and log forms. A log is the inverse of an exponential. The log is the value of the unknown exponent, and our common base is log base 10. Nice job.